Algebra. We are moving on to CO17, which is talking about functions. Folks, we are recording. Kyle, we are recording. Lucas, we are recording. Hayden, we are recording. Talking about functions. And a function is a special type of relation. Okay? A function is defined as a relation in which every x value has exactly one corresponding y value. Perfect line placement. Hits the lines perfectly. A function is a relation in which every x value is exactly one corresponding y value. Okay? And that can be kind of wordy. So we're going to skip right down to the examples of what is a function and what's not a function. Because sometimes when you see it, especially in an XY table, it's a little more clear. So keeping this definition in mind, that a function is a relation in which every x value is exactly one corresponding y. Why are these two here functions? And these two over here not functions? What are you noticing is the difference between the two function tables on the left and the two function tables on the right? That matches this definition with every x value is exactly one corresponding y. Rowan, what do you see?
Because on the not a function on the right, you can see that there's 3 ones with the x, and there's different numbers for each of them. So yeah, that wouldn't be a function.
Yeah. So this one here, he's talking about the one on the far right here. That's not a function because it says every x value is exactly one corresponding y. In this third function table here, the x value of 1 has both a corresponding y of 6, as well as 10, as well as -9. Okay? It's saying that when x is 1, y could be 6, could be 10, or be -9. That is 3 corresponding y's instead of only 1. Do we see a similar thing going on here?
Yes.
With what number?
-2.
-2. When x is at -2, y can't be both 7 and 10. That is not one corresponding y. Whereas the function tables over on the left side here, when x is 2, y is 9. X is 5, y is 7, x is 8, y is 10, x is 4, y is 18. Every x value has only one corresponding y. Same thing here. When x is 1, y is 6, x is 8, y is 10, x is 9, y is 10, x is 12, y is 15. Every x has only one corresponding y. It's okay, right here, that this y repeats itself. Okay? Because we're focusing on the x values and the corresponding y's. So in a nutshell, if you were to summarize this, what would you say in order to be true for a function? What's true with your x values in a function table? If it's a function versus not a function, how would you summarize this whole thing?
An x can only have one y, but an x, I don't know.
Okay? Okay?
X can only have one y, but two y's can also have two different x's.
Okay, even simpler than that. Even. You are correct. But our summary can even be shortened up a little bit more, yeah. Every x needs to be different. X can't repeat itself, basically. If x repeats itself, it's not a function. Because if x repeats itself, that means there's a second y value that corresponds with that x. That's what makes it not a function. You could think about it. This is a great analogy. I wish someone was here observing right now. This is just quality stuff right here. You can think about it as birthdays, right? Is it possible for one person to have more than one birthday?
No.
No.
Yes.
No, right? Every person has exactly one corresponding date on which you were born. That's your birthday. Okay? Is it possible for two people to have the same birthday?
Yes.
Of course it is.
No.
That's kind of what's going on here, right? Or sorry, not here. Here. the person of 8 and the person 9 both have a birthday on the same day. That's okay, that can happen. That's still a function. But over here, -2 is trying to celebrate twice. Can't do that.
Yes, he can.
Stop it. Okay?
It's birthday.
Shh, don't care. You can't do that. Right? So, think about it in that sort of sense. X can't repeat itself. It can only have one birthday. Yeah,
The Y's are like me and Ro, and we have the same birthday.
there you go. Fantastic. Way to connect that to life.
Well, you can't have more than one birthday. Not
Lori.
you. What if you celebrate your half birthday?
It's not your birthday. It's your half. Different. Different. Okay? If you expect to get presents on your half birthday just like you do your actual birthday, that's just being greedy.
Mr. Schultz, you can't have two birthdays, and what if you're born twice? And which birthday was celebrated?
Okay. 3, 2, 1. You are quiet. We have 4 minutes left. I'd love to send you out here without any homework. And in order for that to happen, Lucas, Christian, you're going to have to work together with everybody and quiet yourself down. We'll just go right through the line here. Is this first table a function? Everyone, yay or nay? Is this a function?
Yay!
Yay! X does not repeat itself. Therefore, it is a function. It has only...
Oh, what lagoon is going on with this one?
At this point, if you get homework, you can thank that man.
Thank you.
Now you can thank you.
Right.
Because you're the last one I had to stop for. Okay. The next one.
Nay.
Nay. Why not?
The X repeats
Eddie.
itself.
Because the X repeats itself.
Yeah, Lauren's trying to celebrate her birthday 4 different times. It's my 3/4 birthday. Please give me presents. Okay, no, it doesn't work like that. Okay, not a function. X repeats itself. Third one, is it a function? Yay or nay?
Yay!
Yes, it is. X does not repeat itself. Everything's good. Fourth one, function? Nay. That 8 is a problem. That A repeats itself. Okay. Oh, now it's you. So if you look at the 4 on the bottom that are not function tables, they are graphs. If I cut it off when I scrolled the page down, but you see up above there it says the VLT. Okay, that stands for the vertical line test. Okay, if you've got a function that is graphed, you can use what's called the vertical line test to help determine whether or not it is a function. If you put a vertical line through a graph and it touches that graph in 2 different places, that means X repeats itself, right? Because this would be the ordered pair like 3, 3, and this would be the ordered pair like 3, -2. There are 2 different Y's for the same X. If we were to put this in a function table, it'd be like, 3, 3, 3, -2. You'd immediately say, oh, that's not a function, X repeats itself, right? But it's not in a function table, it's on the coordinate plane, and how you can tell if X repeats, Matt, stay in your bubble please, is that putting that vertical line through the graph, and if it touches the graph in more than one place, it is not a function. So this one, are we all good? Yeah, no matter how many vertical lines I put through it, it only touches the graph in one spot. That is a function, okay? This one here, am I touching the graph more than once?
Yes.
In any one vertical line?
No.
No.
What? Satan.
Okay?
Yay.
I mean, obviously if you draw multiple vertical lines, you'll hit
not
more
on
than
that
once.
one, my bad.
Yeah, we're on the next one. This last one is tough to see. It does not go straight up. This is a function as well. Even though it looks like this goes straight down and straight up, it actually doesn't. It does kind of curve out slightly, but that is a function as well.
Wait.
So there's the vertical line test. Yeah.
If it was right down the line, like on the last one, wouldn't it be meet at all points?
It would not be a function. Right. Yeah. Lucas.
So I know Wilton, you can have 2
Okay.
birthdays.
Anything
No, it's
relevant?
actually, can you,
Are you arguing the 1 birthday, 2 birthday thing?
no, can you, have,
Sounds like you're
celebrate
about to
your birthday
argue.
twice in one day?
Yeah.
It's still one day.
Like 3, 3,
Still one
and
day.
3, 3. Can you have 3,
Okay,
3
well,
twice?
be quiet.
What if you're
Project
joined
Ed.
with
That's 3 twice. 'cause
and
it's
one
the same.
Hey, last one. The ordered pairs of a function are 4, 3, -2, 1, 3, 6, and 0, -5. What is an ordered pair that could be added to make the relation not a function? Lakely, give me one.
4, 5.
4, 5. The reason why it would not be a function is now the x value of 4 repeats itself.
Ooh.
Addie, give me another one.
3,789.
3 and 789. Now the x value of 3 repeats itself. Jude.
-2, 8 million.
-2 and 8 million. Now the value of -2 repeats itself. You get the point. All right. So long, folks. That's my math.